Okay, we're going to talk about correlations or correlational descriptive research, and there are a couple of things that we're going to cover in this little video clip. So, the first thing that we're going to cover is what exactly are correlations, what is correlational research. The next thing that we're going to talk about is how do we determine the strength of the correlation or how strongly variables are related to each other. Next, we'll talk about the direction or the nature of the relationship between two variables. And then finally, we're going to talk about something really important, which is correlation versus causation. So let's go ahead and get started. So correlations or correlational coefficients basically measure whether or not two variables are related to each other. Now, I know this sounds kind of weird, but here's an example of a couple of variables that are really closely related to each other. An example would be your height and your shoe size. Okay, so how are they related? Well, basically, the bigger your shoes, the taller you tend to be. Okay, the smaller your shoe size, the shorter you tend to be. And this is assuming that we're talking about adults here. So height and shoe size would be examples of variables that are highly correlated or highly related. They are so correlated to each other that you can actually tell me what your height is, and if you're an adult and you're telling me the truth, I can guess with really pretty good accuracy how what your shoe size is. So if you tell me your height, I can predict with good accuracy what your shoe size is. If you tell me your shoe size, I can predict pretty accurately what your height is. Okay, I'm not going to be perfect 100% of the time, but I am going to get it right a really large chunk of the time. Okay, now an example of two variables that are not correlated or related to each other would be your height and your IQ. Okay, if you tell me your height, I cannot guess at all with any accuracy what your IQ is likely to be. Okay, conversely, if you tell me your IQ score or your intelligence score, I can't predict at all what your height is likely to be. So these are variables that really have no relationship whatsoever. Okay, so that's kind of the definition of correlation coefficients. Now, in terms of the strength of correlation coefficients, one thing that's really important to remember is that a correlation coefficient is a number that summarizes what the relationship is, how strong it is, what direction it goes in, and that'll hopefully make a little more sense in a little bit. Now, first of all, it's important to know that a correlation coefficient can never be greater than 1.0. It can be 0.8, it can be 0.99, it can even be 1.0, but it can't be any bigger than that. It can't be 1.1, it can't be 3.6. Okay. Similarly, a correlation coefficient can't be any less than -1. So it can be -7, -0.99, -1.0, but it can't be any less than -1. Okay, so if someone claims that they've gotten a correlation coefficient of -2.58, they really have just told you that they've done the math wrong. That's really all that they're telling you. So they really need to go back and recalculate that equation. Okay, so basically, the closer a correlation coefficient gets to 1 or -1, the stronger the relationship between the two variables. So with height and shoe size, the bigger your feet, the taller you are. That's probably a correlation of about 0.8, 0.85. If you tell me your shoe size, I can't be accurate 100% of the time, but I'm going to be accurate a lot. Okay. Now, a stronger correlation than 0.85 would be 0.9 or 0.95. Okay. Similarly, a point or a -0.85 correlation would be equally as strong as a +0.85. And we'll get into what the positive versus negative means in just a second. Okay, now if the correlation coefficient gets close to 0, meaning zero point 0.1 or negative 0.05, then we're talking about two variables that really aren't related at all, kind of like your height and your IQ score. Okay, so now with the positive and negative, this is when we start getting into the direction, okay, or the nature of how the variables are related. So a positive correlation is simply meaning that as one variable increases, the other variable increases too. Okay, similarly, as one variable decreases, the other variable increases too. So back to height and shoe size, as your height goes up, your shoe size is going to go up. As your height goes down, shoe size is also going to go down. Okay, so the variables are increasing and decreasing in the same direction together. The negative correlation, by contrast, is a little bit different. Basically, as one variable goes up, the other variable goes down in value. So, for example, the more classes you miss, if your class is actually meeting, the more class sessions that you miss, the lower your grade is likely to be. Okay, another one would be, and this is getting kind of gross, but the more days you go without bathing in the summer, the fewer people who are going to want to be around you. Okay, so as one variable goes up, the other one goes down. Now, probably the most important and the most missed issue on the exam is the whole correlation causation issue. Okay, now if I'm able to predict that because of my knowledge of one variable, I can predict where you're going to fall on another one, it's really easy to think that this means that one variable causes the other. Okay, when in actuality it doesn't. Even though your height and your shoe size are very highly correlated and I can make those predictions, it would be ridiculous to say that your height caused your shoe size or that your shoe size caused your height. Okay, but what about an example of the more you smoke, the more likely you are to get lung cancer? Okay, there it becomes a little bit more tempting to say that smoking causes lung cancer based on that information. And the fact of the matter is, we really can't. Okay, yes, the more you smoke, the more likely you are to get lung cancer. That's absolutely true, but we don't know if that means that smoking causes cancer, or if having lung cancer causes you to smoke, or if there's something else that we just haven't talked about yet that might cause people to both smoke and be at higher risk for lung cancer. So one thing that's really important to remember is that just because two variables are highly correlated and so strongly related that we can make predictions based on your knowledge of one variable, that does not mean that one variable causes the other. The only way that we can determine cause for sure is through an experimental design. And we'll talk about experiments in another video clip.